The sun comes out and it's a new day. I'm gonna make it on my own. The sun comes out, I'm in a new way. I gotta pack my things, I'm going home. Let's build a house, we'll have a backyard, something beautiful, something with a view. Let's build a house just for me and you. straight, stand over there, wanna run.
Welcome. Thank you for joining. Our session will begin soon.
A hand to hold when the road looks rough. The times you learn how to toughen up. Call it an instinct, no time to rethink. Just acting in the moment. Smoke rolling out the window. A selfless hero. Brave, keep being brave. One chance to save somebody when they need you. Going against the grain. Don't be afraid. Yeah, all it takes is being brave. Walking up to the battle line. First watch lasting through the whole night. Call it an instinct, no time to rethink. Just acting in the moment. Smoke rolling out the windows. A selfless hero. Brave, keep being brave. One chance to save somebody when they need you. Going against the grain. Don't be afraid. Yeah, all it takes is being brave. Brave, keep being brave. One chance to save somebody.
Hello, everyone, and welcome to Effective Machine Learning with Cloud TPUs. I'm delighted to see all of you here, and I'd like to send a special welcome to everyone on the live stream or anyone who's watching this as a recording later. I'm Zach Stone. I'm the product manager for TensorFlow and Cloud TPUs on the Google Brain team, and this talk is about supercomputers for machine learning that are built around Google's custom chips called tensor processing units. Number of multiply adds, which is sort of a rough metric of computational cost on the horizontal axis. And as you can see, as you get to these higher and higher accuracies, you're actually requiring larger and larger amounts of computation. So the solution to this problem, we believe, is specialized hardware for machine learning. And that's what's really driven us to develop these multiple generations of tensor processing units, or TPUs. Our first TPUs have been in our data center since 2015, and you've interacted with these every time you've run a search. They're re-ranking the last several hundred links to choose the 10 that they're showing you. They've been a central part of Google Photos and speech recognition and many of Google's large-scale applications that you use every day. Last year, we revealed our second generation tensor processing units, which are now in public beta. Anyone can sign up. Any GCP project can start a Cloud TPU, and you can follow the link g.co/cloudtpu to learn more. These TPUs aren't just for training and inference on a single system, though. They're really designed to be connected together into these large-scale supercomputers that we call TPU pods. And later this year, TPU pods are coming to cloud as Cloud TPU pods. Here's a full pod of the second generation TPUs on the screen right now. Finally, this morning, you're getting the first glimpse of our third generation TPUs assembled into an even larger TPU pod that delivers more than 100 petaflops of compute for a single machine learning problem. So I just want to emphasize that we are committed to making relentless progress in this domain. This affects all of our products. It improves the lives of all of our users. And through the cloud, we're bringing these platforms to you so you can train machine learning models and run them faster and more cost effectively than ever before. Just a few notes on performance. You can see TPU v1 with 92 teraops only doing inference, then going to the Cloud TPU, which is 180 teraflops. Suddenly you have floating point. It's a lot easier to work with. You don't have to worry about quantization. And those are connected together into these systems that, as I mentioned before, are up to 11.5 petaflops and do training and inference, either on a single problem, or you can slice them into smaller pieces to do many different problems at once. Just a year later now, we're making this leap from about 11.5 petaflops to more than 100. That's more than 8x the performance of a TPU v2 pod in this new v3 system. And that's a combination of an entirely new chip wired together into an even larger scale system. So I hope the reason that you're all here is because you're interested in expanding the AI frontier. That's what really motivates us when we're developing these platforms and building applications on top of them. Now, I'd really like to focus on what you can do right now with the Cloud TPUs that are available today. And that really starts with performance. A lot of these machine learning models can take days or weeks to train. It hasn't been uncommon in the past for it to cost thousands of dollars just to do one training run of these machine learning models. And we're really interested in bringing down those costs and making machine learning acceleration much more widely available. But when we're talking about performance, it's important to be very specific about what we mean, because it's quite subtle sometimes to compare one system to another. First of all, in all of our measurements, we try to focus on real-world data, time to accuracy, and cost. So let me tell you what I mean. When you're training a machine learning model and you're processing millions of images, it's convenient to look at how many samples a second you're processing as a measure of performance. But those samples per second numbers don't matter unless you ultimately get where you need to go, reach the correct final accuracy. And so what we're really looking to do is, yes, measure how fast the wheels are spinning on the car, but also make sure that the car gets to the right destination and crosses the finish line. So it's very important whenever you're considering building, buying, renting a machine learning system to make sure that you're asking about not only steps per second or samples per second, but also the training accuracy and the total time to accomplish the task that you really have in mind. We've also put in a lot of energy to try and make sure that all these ML benchmarks that we talk about are reproducible via open source. So almost all the numbers that I'm about to show you, either you can reproduce today by going to g.co/cloudtpu and renting a Cloud TPU, or they'll be open source soon, and so you'll be able to reproduce them on your own. You don't just have to take my word for it. Now, Stanford recently hosted a competition called DawnBench. I've got a screenshot of the website here. And DawnBench is the first public benchmark challenge that we've seen really measure performance and accuracy together, which we think was great. There was active participation from many different companies and individuals and research groups. And I'm happy to announce that Cloud TPUs and TPU pods did very well across several of the categories. So in the ImageNet training cost competition, we had the #1 DawnBench entry with a model called AmoebaNet-D. Now, this is a really interesting fusion of some of the work that we've been doing in research with these new hardware platforms, because AmoebaNet was an architecture that was actually evolved from scratch on TPUs. And then that model, not only if you train it longer, can get to state-of-the-art accuracy on ImageNet, but it can hit the target that DawnBench set of 93% in just 7.5 hours for under $50. This really makes this kind of state-of-the-art performance accessible to a much wider audience than it's ever been before. Now, another model that you may have heard of that's frequently benchmarked is ResNet-50. And so I just wanted to show a quick case study of ResNet-50 running with TensorFlow 1.8, which is our most recent version. We also submitted this to DawnBench, and it also reaches this accuracy of 93%, which is not, this is top 5 accuracy, that's not easy to do with ResNet. It's easy to fall just a little bit short, and you have to be very careful throughout the implementation to achieve that high accuracy while maintaining this incredible performance of more than 3250 images per second. Now, this took almost 9 hours to train for $59, but if you want to go faster, part of the reason that we designed these systems to be connected together is just by changing the batch size of the model. No code changes, no complicated thinking about distributed systems. We can run the same thing on half of one of these TPU pods to hit the same level of accuracy in just 30 minutes. So that's 9 hours down to 30 minutes. And these are the pods that are coming to cloud later this year. So you'll be able to run results like this on your own or train on other models with other data sets of your own. And if you eliminate the checkpoint overhead, which DawnBench didn't actually require us to measure, that's actually just 24 minutes. So what I'd like to mention, though, is the field is moving extremely fast. So just as an example, the third place entry for training cost on DawnBench was from a nonprofit organization called Fast.ai. And that entry came in at $72, but it included some really interesting ideas that weren't well known. One was this progressive scaling up of training images that enabled the model to move even faster in the earlier phases of training when it's just starting to figure out how to complete the task. And they also used a much more aggressive learning rate schedule that hadn't been widely used. The nice thing about Cloud TPUs, it was easy for us to make these open changes in our own model on Cloud TPU and unofficially rerun the experiment. And these two simple changes take our ResNet 50 training cost from $59 down to just $25 with today's on-demand pricing that you can get on Google Cloud. So there's an open source reference implementation available. We've built this into our bfloat 16 version of ResNet 50, and we'll have more to say about this soon. But kudos to Fast.ai for the great algorithmic improvements. And I'm just delighted as a researcher and practitioner and now product manager that so much of this progress is widely shared. So you might be wondering, well, what's the next benchmark challenge? DawnBench finished recently. Where do we go next to compare these very different systems of different sizes and scales and even different model architectures against one another if we need to make a decision about what to do when you want to accomplish a goal? Well, one new challenge that's been released recently is MLPerf. You can learn more about it at mlperf.org. There are a bunch of researchers from different top universities and also many companies coming together to try and define a new next-generation benchmark that's even more challenging than DawnBench and covers many more problem domains. The first deadline is going to be in July. This group is open to new collaborators and also planning to iterate on the definition of the benchmark to make sure that it really tracks where the field is going. So I think this is going to be really exciting later this year, and I encourage you to participate and check it out. And as I've mentioned before, I just want to provide a little bit more information about what you can do today with Cloud TPUs if you want to experience this kind of performance. We've got this set of reference models. I'll say more about them in a minute, but they're right there on GitHub/TensorFlow/TPU. And we've also got great documentation on the Cloud TPU website with the link below. But you don't have to remember the big links at the top. Just g.co/cloud/cloudtpu will take you where you need to go. So now I'd like to give you a sense of what it's like hands-on to use these Cloud TPUs. First of all, one thing that's a little different than other accelerators is that they're network attached. So what that means is you can choose a virtual machine of any size or shape. You can attach other accelerators to it if you want. It can be large. But you would generally start with a very tiny VM because this is really playing just a coordinating role. As few as 4 cores are often enough because all the real computational work is happening on the Cloud TPU. The nice thing about this setup is that Cloud TPU can be a single device, or it can be a slice of one of those pods. You don't have to worry about it. All that's handled for you. Furthermore, you don't have to worry about messing with drivers. You can just use these machine images that we provide. You program these Cloud TPUs with TensorFlow. Now, TensorFlow is the most popular open source framework for machine learning, one of the top projects on GitHub. And it's just taken off since it was open sourced in November of 2015. We're now up to something like 13 million downloads all around the world. TensorFlow supports many different kinds of machine learning and has many different components. When you're programming Cloud TPUs today, you'll focus on layers, estimators, the tf.data fast input pipelines, and then your code will be transformed behind the scenes by the XLA compiler to talk to the TPU. So estimators and layers really provide these flexible, high-level deep learning abstractions for TensorFlow that let you map a wide variety of different models to TPUs. Here's just a quick code sample of a convolutional neural network. And this is how you would write it with layers and estimators with some code elided. What you can see here is that you just have to make some minimal changes to map this over to the TPU. Changes in the optimizer and the estimator. And we're working over time to make these changes smaller and smaller so that it'll be really convenient for you to take TensorFlow code that runs on CPUs or GPUs, run it on TPUs, move back and forth wherever you need to take your code and train or run. One important bit of advice, though, that I'd like to just emphasize over and over. High-performance computing is hard on any platform. And these accelerators are so fast that you need to really put in a lot of energy to make sure that the whole system is balanced and that every part of it is performing as well as it possibly can. We've done a tremendous amount of this work for you with these reference models that I'm about to show you that we've got open source on GitHub. For example, here are 4 different categories of very different applications that are either supported today or are about to be open sourced for Cloud TPU. Over in the image recognition column, which is maybe best known, we've got AmoebaNet and ResNet 50, also bigger versions of it, Inception v2, v3, v4. But we can also do object detection with RetinaNet, which is another one of these recent state-of-the-art models, and I'll say more about that in a minute. Also, if you're interested in training a machine learning model and then deploying it at the edge on a phone or a robot or a drone or in a vehicle or somewhere else, you might want to train a smaller model with something like MobileNet or SqueezeNet, and Cloud TPUs support those as well. But we're not limited to just image recognition or object detection. TPUs can also do machine translation and language modeling, sentiment analysis, question answering, all with this state-of-the-art model architecture called Transformer that's very powerful and flexible. Turns out a version of Transformer can also perform fantastic speech recognition. And we've just recently open-sourced an example of speech recognition training on Cloud TPUs as part of the tensor-to-tensor framework. I'll tell you more about that in a minute. And finally, for those of you who are researchers out there and are at the cutting edge where you're generating images from scratch, over in the image generation category, we've got the image transformer and also DC GAN. So we've really got a huge range of applications that are not only possible to make work on the Cloud TPU, but they're working today with open source code that you can just download. It's a really easy way to get started. So for those of you who aren't as familiar with this domain, image classification is often taking these small images like this one and mapping that to a category like lion, whereas object detection is taking a larger images and looking for many different objects in many different places in the image. The cool thing about our RetinaNet implementation is it lets you process quite large images, 896 by 896, trains to a very interesting accuracy on the COCO dataset, 37 average precision, in just 6 hours for $40. Machine translation, training on the WMT dataset, gets to a blue score of 28.6, which is very close to the state of the art. Again, in just 6.2 hours for $41. And these results are, changing all the time as we continue to optimize the platform, the implementations, and new research comes out, much of which at Google is conducted on these TPUs. Now, language modeling, you're trying to predict the next word. This is an important component of applications like Smart Reply. And again, you can take the language modeling, the LM1B, the 1 billion word data set, and train to a state-of-the-art perplexity of 28 in 74 hours for under $500. And I've mentioned tensor-to-tensor again below. That's this open source project built on top of TensorFlow that has some of the latest and greatest results for all of these sequence-to-sequence models. For speech recognition, we've got this model called ASR Transformer, which is training on LibreSpeech, again, to a really interesting word error rate. This is a fantastic way, if you have a large labeled speech data set, to just train your own near state-of-the-art speech recognition model from scratch in whatever language or accent you care about. And you can get to a reasonable accuracy for under $100. Finally, question answering here with QANet. This is just the fast version that we use to win the question answering competition for Dawnbench. But there's a Stanford question and answer data set that takes a big chunk of text and then presents a question about some fact that you can infer from reading the text. So this machine learning model is actually looking at this whole paragraph of unstructured text, reading the question, and then pinpointing the answer. It's really impressive. It's really different from image recognition, and all this is possible on this sort of flexible, new, powerful platform for machine learning. Oh, I forgot, I was going to tell you a little bit more about image generation. So the metric here is actually bits per dimension, and lower is better. State of the art is around 2.92 right now, but under 3 is really good. And you can get under 3 on this metric in 30 hours for under $200 if you're interested in exploring this state-of-the-art, cutting-edge image generation examples. All those images on the right were generated from scratch, just dreaming on the basis of a training set using this image transformer model. So again, why start with a reference model instead of just opening a code editor and starting from scratch? Well, these reference models are high performance, they're open source, they're cutting edge, often collecting input from researchers all across Alphabet. We continuously test them for performance and accuracy, which means that you don't have to worry that some subtle change in TensorFlow or some other part of the stack might reduce the accuracy without you realizing it. You can get up and running really quickly and then modify as needed because you have the code. It's yours on your infrastructure, and you can train and run on your own data. But you're perfectly welcome to do it the hard way. We have lots of detailed technical advice in our troubleshooting guide, and I'm not kidding that high-performance computing is hard, and any part of the system can become a bottleneck, but we totally encourage you to take the high-level layers and estimators APIs and build new models, and let us know what works for you. Just to give you a little bit of a sense of what makes high-performance computing so tricky, if you're training with slower hardware, you might find that you can overlap your input preprocessing with your training time, and so your accelerators are always saturated. But when the accelerators get a lot faster, what you find all of a sudden is that you're bottlenecked on the input processing, and your accelerators are sitting idle. And so, fortunately, we've provided a bunch of tools that are connected into TensorBoard, which is this great visualization framework associated with TensorFlow, to help you debug your performance, understand what's going on. Here I'm showing the steps per second and the loss. But we actually have this very detailed profiler that lets you go in and get op-by-op statistics on what's going on in your model. And we even have high-level recommendations. I don't know if you can read the red text, but it's telling you, in this case, your model is not input-bound, so you should spend more time on optimizing the step performance. In other cases, it'll tell you, you're blocked on input. Don't bother improving the speed of your model. You need a faster input pipeline, and that's where TF data can help. So we're really doing our best to present these tools for experts and all this documentation for experts, but also to make it really easy to get started with these reference models across this huge range of applications. Now, those of you who are used to training and running machine learning models under your desk, you might wonder, well, why should I jump to the cloud? That seems like a different platform. How do I think about that? The nice thing about training in the cloud is that you get access to all this top-notch infrastructure where you can mix and match the different components you need, like those custom VM shapes I was telling you about earlier. You can scale up and down quickly. You don't need to order hardware, maybe build a machine yourself, wait for months sometimes for hardware to arrive. You can just sign on today and scale up to hundreds of TPUs if you wish. There's great security all throughout Google Cloud. Google is state-of-the-art in security across the entire platform for enterprises that want cutting-edge machine learning hardware. And you're really able to reduce your capital expenditure. With this on-demand pricing, you're just paying only for what you use. You can train one of these models for $50 and then turn the Cloud TPU off, and you're not paying for it anymore, which is great. So just a few words from two of our customers for Cloud TPUs. 2 Sigma is a financial firm, and Lyft, this is their self-driving vehicle team. Both of them have had great experiences using Cloud TPUs to focus on building the models instead of worrying about these massive distributed clusters of other hardware and taking these models that used to train for days in some cases down to hours. And with these larger and larger pods, we're really trying to drive that to minutes. So let's go under the hood and talk in a little bit more detail about what's going on in the current generation of Cloud TPU. So first of all, the Cloud TPU actually includes a host with this accelerator, all behind the scenes, connected via PCI. Each Cloud TPU device has these 4 chips under the heat sinks here, and I'm going to zoom in on one of them. If you look at the Cloud TPU chip layout, you'll see that it's broken down into 2 cores that look like this. Now, these cores are really built around this systolic array, which is an old idea, but it's newly relevant in this age of machine learning, when so many of the computations really look like gigantic matrix multiplies. But we've also got a vector unit and a scalar unit, and in this case, it was 8 gigabytes of high bandwidth memory per core, and then there are 2 cores per chip. The new TPU v3 actually doubles the memory per chip, which is going to let you train even larger and more capable models. Focusing in on this matrix unit, this systolic array, one thing that's really interesting about it is that we're actually doing the multiplies with a new floating point format that's called bfloat16. I'll say more about that in a minute, but it really gives us this great performance for machine learning without a meaningful cost in accuracy. We're still accumulating in float32, though. So most of you are probably familiar with 32-bit floating point. As you can see here, the orange mantissa bits are all devoted to measuring these fine differences between numbers, which is really important if you're doing high-performance computing, detailed simulations, that kind of thing. But in machine learning, it turns out that the range is much more important. And these machine learning models are not super sensitive to these fine differences, by and large. So the IEEE standard for a 16-bit floating point truncates both the exponent and the mantissa, as you can see here, and it really cuts down the range of numbers that you can express. One thing that we're finding with TensorFlow is if you're training with half-precision IEEE like this, you really have to pay attention, and you need to get an expert involved on a model-by-model basis to make sure that all of your numbers stay in the right range and don't overflow, and those techniques are difficult to apply in general across a wide range of models. With bfloat16, though, what we've done instead is saved a lot more bits for the exponent, which preserves the range. And so in many models, this is a drop-in replacement for float32, and it's supported seamlessly by our Cloud TPU hardware. So those ResNet 50 results that I was talking about earlier, those were achieved with bfloat16. And as you notice, we're still achieving that high 76% top 1 or 93% top 5 accuracy with a minimum of effort and special casing on a model-by-model basis. So here I'll show you a brief animation of the systolic array. In this slide, it's only 3 by 3, but imagine this is 128 by 128 to get a sense of how different this is from an ordinary central processing unit and how much parallelism there is, which is where we're getting this fantastic performance. So here you have data streaming in, and what's happening as the systolic array sort of beats on every step is you're getting great reuse of these intermediate results as the data is flowing through the systolic array and generating the outputs. So this is super high throughput for matrix multiplications, and is tightly integrated with the other parts of our TPU that support all these other custom operations. And our XLA compiler also does a great job of taking high-level mathematical expressions and then mapping them down into this coordinated dance of low-level operations that gives this tremendous amount of speed. So where do we go from here? Well, first of all, I really want to emphasize something I haven't called out explicitly about scaling up. I think the days of single systems are irrelevant. They're over, because what you care about ultimately is how fast you get to your result, right? And so what we're trying to do with these Cloud TPUs and making them widely available in the cloud is giving you just a dial that you can turn where you do your prototyping on an inexpensive single device, and then you increase the batch size without doing any other code changes, and suddenly your training time is going down from hours to minutes. And so I'll show you two real measurements from our TPU systems in-house here to give you a sense of how that's possible. First of all, what I'm demonstrating here, if you look at these TPU devices, so the second generation TPU pod has 64 of these boards in it. And you can see linear scaling of images per second up and to the right here. And as you know, remember, if you hear images per second, it's like, but wait, what about the accuracy? You can check our Dawnbench results. That 30-minute result also confirms that we can still get the high accuracy with this scale out. But what you can see is that our interconnect in this pod is so fast that you don't have to struggle the way you would with mixing and matching hardware on your own, whether on-premise or in the cloud. You can just turn this dial with no code changes and benefit from this super fast proprietary network. But there's a more subtle point here that's a mathematical issue, which is until recently, it hasn't been clear how to take these machine learning models and increase the batch size, which is how many of these images you're processing simultaneously, sort of in each step while you're training. There's been a huge amount of research energy on this recently, and there have been a lot of breakthroughs where we're now able to train effectively on much larger batch sizes from ever before. That's great news for scaling up with these TPU pods. Let me help you interpret this graph. What you see on the horizontal axis here is time, and then what you see on the vertical axis is accuracy. And so you might imagine, your first implementation on your Cloud TPU that you're renting today gets to, let's say, 76% accuracy on ResNet 50, and that takes a certain amount of time. That's that orange curve out there. But with no code changes, just by changing the batch size in the right way with the models that we've already open sourced, you can pull that time in as you're using larger and larger sections of the pod, until you get down to these 30-minute results or possibly even better. So we think this is an extremely promising research direction, and we're doing our best in all these reference implementations to make sure that it's immediately accessible to you. So once these pods become more widely available in cloud, then you'll be able to just transparently benefit from this large batch training. I'd love to live in a world where you can use an exaflop for a minute and then let it go and think for a while somebody else is using it and just swap back and forth. Now, here's another view of the full TPU v3 pod that Sundar showed you this morning. And we are doing everything that we can to push the boundaries of performance, and that's what's really led us to liquid cool this pod in comparison to everything that we've done previously that's air-cooled. If you want a cool close-up view, here it is, a close-up view of just one of the boards in that pod. It looks sort of like this, and you can see the tubing. Now those plates are on each one of these next-generation TPU v3 processors. So we're going to go to the largest batch sizes we can. We're publishing all this research that we're doing. We're open sourcing as much of it as we can on these Cloud TPU platforms that you can access today. And so we're really excited in going with you into this exciting AI frontier. You can get started right now with these high-performance reference models and tutorials. And please reach out to us. Let us know. We'd be really interested in hearing your feedback on the Cloud TPU platform of today. We'd love to know where you'd like it to go. We hope you enjoy trying all these different applications across image recognition and speech recognition and image generation and machine translation. And I'd be happy to take some of your questions offline after the talk. So thank you very much for listening. I've included some links here. Thanks again.
Down, 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 pull you out. Now, 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 'cause you're in my dreams, so haunting me, and I do
Hello and welcome to I/O Live. I'm Florina Montanescu, your host, and I'm here with Harris, product manager on Android Auto. Hi Harris.
Hi Florina.
So tell me, what's new for developers for Android Auto?
So this is a very exciting year. We have all the new sets of the changes in the APIs for media and messaging developers, which is the biggest change that we made in a long while. For the media, what the developers can do is they're going to be able to do content browse forward, which is pretty exciting, and they're going to have a different sets of layouts that they can use to actually present their content better to the user. For the messaging, we have new messaging styles, which is going to enable them to do, for example, group chat and a couple of different things. And for all the thousands of developers that we have for Android Auto, that's pretty exciting.
Am I able to already download the apps directly in the car?
Yeah, so actually what we have right now is we're also showcasing the preview of the Play Store Google Assistant in the vehicles. So we've announced today that we're going to be shipping some of these Google services with Volvo, so that's pretty exciting.
That's cool. Anything else that you want to tell us?
No, it's like I would say is like keep developing for Android Auto. If you're media messaging apps, we're excited to work with you.
Perfect. Then check out the documentation that we have online and start developing Android apps. Thank you.
Thanks.
This is Florina for I/O Live.
Hello and welcome back to I/O Live. I'm Timothy Jordan and I'm standing here with Jorge. Jorge has been applying machine learning to diabetic retinopathy detection. Hi Jorge, thanks for joining us.
Hi, nice to be here.
Okay, let's start with what is diabetic retinopathy?
So diabetic retinopathy is the main cause of blindness among working age adults in the world. And the sad thing is that it's 90% preventable if patients would get regular eye exams and timely treatment. The problem is that people don't get regular eye exams, and so we've been going out and getting images of the retina in order to get a diagnosis to see who is at risk for vision impairment.
And how do you apply machine learning to the problem?
So right now, an ophthalmologist or an eye doctor, optometrist has to look at the image and determine what the level of retinal disease is before a patient can be referred, if they need referral for treatment. So with AI, you can get an immediate grading of what's going on in the retina. So you don't have to wait sometimes an hour, 2 hours, or 2 or 3 days, or even weeks to get a response. You can act immediately for people that need care.
And I imagine this is a scalable thing as well for areas that don't have access to the same medical help.
Right, so vision impairment is expected to increase by 3 times by the year 2050.
Wow.
And so there's just not enough manpower. There's not enough eye doctors in the world to be able to take care of everyone. So this is really the only chance to be able to get the people who need care into treatment, to be able to identify them and make sure that they're able to get treated.
I see.
Yeah.
What's next after this? What else do you think that you can apply machine learning to for people?
Yeah, so that's really exciting. It looks like AI can see a lot of things in the retina that humans can't. So we're looking to apply it to cardiovascular disease, neurological disease, and a host of other problems that we're hoping, that the algorithm can find out with just a simple retinal image.
Awesome. Jorge, thanks for sharing your story, and thank you for the work that you're doing.
Thank you.
I'm Timothy Jordan, and this is I/O Live.
Hearing my parents playing guitar, that's probably my first memory. When I started learning about how sound waves are just vibrations in the air, my eyes opened to like a new world. And that's, I think, when it clicked that I knew I wanted to do engineering.
Daniel had a musical background. That's an important part of working on audio, is you have to have an understanding of the way sound works.
The scientists at Embari wanted to figure out a way to, in any given day, count how many blue whales there were.
So the process involves recording audio from the ocean, but it's too much information for a human to try to look at and listen to.
We were able to turn those sounds to spectrograms, which are just images of what sound looks like, and fed those images into TensorFlow, this machine learning tool.
It allows us to take a mammoth pile of data and distill it into something meaningful.
It can answer a lot of questions about the way we are affecting the marine environment and how we can help conserve it. When I was a kid, I didn't think I was going to be a scientist or an engineer, but knowing that I'll never stop learning makes me feel pretty lucky.
Hello and welcome to I/O Live. I'm Florina Montanescu, your host, and I'm here with Harris, product manager on Android Auto. Hi Harris.
Hi Florina.
So tell me, what's new for developers for Android Auto?
So this is a very exciting year. We have all the new sets of the changes in the APIs for media and messaging developers, which is the biggest change that we made in a long while. For the media, what the developers can do is they're going to be able to do content browse forward, which is pretty exciting, and they're going to have a different sets of layouts that they can use to actually present their content better to the user. For the messaging, we have new messaging styles, which is going to enable them to do, for example, group chat and a couple of different things. And for all the thousands of developers that we have for Android Auto, that's pretty exciting.
Am I able to already download the apps directly in the car?
Yeah, so actually what we have right now is we're also showcasing the preview of the Play Store Google Assistant in the vehicles. So we've announced today that we're going to be shipping some of these Google services with Volvo, so that's pretty exciting.
That's cool. Anything else that you want to tell us?
No, it's like I would say is like keep developing for Android Auto. If you're media messaging apps, we're excited to work with you.
Perfect. Then check out the documentation that we have online and start developing Android apps. Thank you.
Thanks.
This is Florina for I/O Live.
Hello and welcome back to I/O Live. I'm Timothy Jordan and I'm standing here with Jorge. Jorge has been applying machine learning to diabetic retinopathy detection. Hi Jorge, thanks for joining us.
Hi, nice to be here.
Okay, let's start with what is diabetic retinopathy?
So diabetic retinopathy is the main cause of blindness among working age adults in the world. And the sad thing is that it's 90% preventable if patients would get regular eye exams and timely treatment. The problem is that people don't get regular eye exams, and so we've been going out and getting images of the retina in order to get a diagnosis to see who is at risk for vision impairment.
And how do you apply machine learning to the problem?
So right now, an ophthalmologist or an eye doctor, optometrist has to look at the image and determine what the level of retinal disease is before a patient can be referred, you know, if they need referral for treatment. So with AI, you can get an immediate grading of what's going on in the retina. So you don't have to wait sometimes an hour, 2 hours, or 2 or 3 days, or even weeks to get a response. You can act immediately for people that need care.
And I imagine this is a scalable thing as well for areas that don't have access to the same medical help.
Right. So vision impairment is expected to increase by 3 times by the year 2050. Wow. And so there's just not enough manpower. There's not enough eye doctors in the world to be able to take care of everyone. So this is really the only chance to be able to get the people who need care into treatment, to be able to identify them and make sure that they're able to get treated.
I see. Yeah. What's next after this? What else do you think that you can apply machine learning to for people?
Yeah, so that's really exciting. It looks like AI can see a lot of things in the retina that humans can't. So we're looking to apply it to cardiovascular disease, neurological disease, and a host of other problems that we're hoping, you know, that the algorithm can find out with just a simple retinal image.
Awesome. Jorge, thanks for sharing your story, and thank you for the work that you're doing.
Thank you.
I'm Timothy Jordan, and this is I/O Live.
Hearing my parents playing guitar, that's probably my first memory. When I started learning about how sound waves are just vibrations in the air, my eyes opened to like a new world. And that's, I think, when it clicked that I knew I wanted to do engineering.
Daniel had a musical background. That's an important part of working on audio, is you have to have an understanding of the way sound works.
The scientists at Embari wanted to figure out a way to, in any given day, count how many blue whales there were.
So the process involves recording audio from the ocean, but it's too much information for a human to try to look at and listen to.
We were able to turn those sounds to spectrograms, which are just images of what sound looks like, and fed those images into TensorFlow, this machine learning tool.
It allows us to take a mammoth pile of data and distill it into something meaningful.
It can answer a lot of questions about the way we are affecting the marine environment and how we can help conserve it. When I was a kid, I didn't think I was going to be a scientist or an engineer, but knowing that I'll never stop learning makes me feel pretty lucky.
Good afternoon, everybody, and welcome. Today's session is all about app performance. My name is Joel Newman, and I'm a product specialist on the Google Play business development team. In that capacity, I've worked with Android developers of all shapes and sizes, helping them to leverage the tools available in the Google Play console to build successful app businesses. Now, I'm going to kick things off with a quick reminder of just how important performance is to app business success, and why Android Vitals can be a critical tool in helping you improve your performance. Then my colleague Fergus, product manager for Android Vitals, will join me on stage to talk about some of the ways we're enhancing the platform to make it easier to understand and action your performance information. Then my colleague Wojtek from our developer relations team will come on stage for a technical deep dive to talk through some of the common causes of performance issues and how to address them. Finally, we'll wrap things up by talking about some of the resources available within the Play console itself and beyond to improve your performance. And if we have time, we'll try to do a brief Q&A. Now, first, I think it's important to remind ourselves of why performance is important. Now, I think this is intuitive, right? Like, we as users, nobody wants to deal with an app that crashes frequently or freezes or is janky. But at Google Play, we have data that drives home just how important performance is. We did an analysis of all the reviews on the Google Play Store over the past year and found that when leaving a one-star review, over 40% of the time, users cited negative performance indicators like stability and bugs. In fact, this was the #1 cited issue within one-star reviews. Now, on the flip side, when leaving 5-star reviews, over 70% of users mentioned positive performance indicators, things like speed, design, and usability. Now, why is this important? Well, not only are ratings and reviews a direct and leading indicator of customer satisfaction, and not only do ratings figure heavily in the Play Store search algorithm, but ratings and reviews correlate strongly with downstream business KPIs, things like engagement, retention, and monetization. A great example of how that performance can impact key business KPIs, it comes from this study. We did an analysis of all of the games in Google Play, and we compared those with the lowest crash rate versus those with the highest crash rate. And we found apps with the lower crash rate saw almost 2.5 minutes more of gameplay per day. And this was even a bigger trend when we looked at ANRs, which are more frequently looked over relative to crash rate. We found that users spent almost 3 minutes more per day in the more stable apps. And this may not sound like a ton of time, but when you look at this over a yearly basis, this would translate into 18 hours of additional gameplay per user for games that are played on a daily basis. Now, another reason why performance is incredibly important is that it's becoming an increasingly important signal within Google Play for both search and discovery. As Google Play is committed to surfacing only the highest content to our users, we're increasingly taking into account performance signals, particularly those related to stability and battery consumption in both our Play Store search algorithm as well as our algorithmically generated recommendations. And in addition to that, performance signals factor heavily into our decisions around our editorially curated content. This includes our featured new and updated apps collection, as well as Editor's Choice and coveted Google Play Awards and Android Excellence. If you want your app business to succeed, your app needs to be discovered. And technical performance is an increasing part of that discovery within the Play Store. Now, it's exactly because of that increasing importance of technical performance that we launched Android Vitals last year. Android Vitals is an initiative by Google to improve the stability and performance of Android devices by surfacing to the developers in an easily understandable and readily accessible way the most important performance metrics in battery, stability, and rendering. This comes from over 100 million users who have opted in to share the data with Google and with you, our developer partners. And since the program's launch a year ago, it's been an incredible success. We have over 100,000 developers, including some of the biggest names on the Android platform, regularly engaging with the Vitals console to understand their performance issue and create fixes. Now, it's because of this incredible engagement that we've seen some really nice gains at an ecosystem level. When we compared reviews in the Play Store today versus a year ago before we launched Vitals, we see a really nice uptick in those people leaving 5-star reviews talking about things like speed, design, and usability. But perhaps more importantly, when we look at people leaving 1-star reviews, we've seen an almost 20% decrease in the number of people talking about things like stability and bugs and battery consumption. And that's only possible because of the incredible work that you have done as a developer community to up the quality of Android apps. And for those of you who are new to the platform, it's really important that you keep pace with the rest of the developer community who is helping us move in a positive performance direction. Now, I think where these gains at an ecosystem level are interesting, you might wonder as an individual developer, yeah, but how does that really matter to me? Well, I want to showcase a couple of examples of where individual developers have seen incredible gains because of Android Vitals. One of my favorite case studies is Starbucks. Now, Starbucks is obviously an incredibly popular app. They have over 15 million downloads on the Google Play Store. They started using Android Vitals in December, admittedly several months after the launch of the program. And when they started using Android Vitals, they were alerted to ANR issues that were not even on their radar. And they were able to use the reporting in the console to identify common underlying causes for the ANRs that were caused by a third-party library. They removed that third-party library and saw a 70% reduction in ANR rate within a week. Now, they saw a similar and actually even better experience with crash rate. Because Android Vitals is a platform-level tool, it's able to detect crashes that were not detected by Starbucks' third-party Crash SDK, because these crashes were happening at app start before Starbucks' third-party Crash SDK had even initiated. Using the Vitals reporting, they were able to identify an underlying cause, push a fix, and they saw an 85% reduction in crash rate within a week. These are impressive stats. Now, it's worth calling out that Vitals, and this is a common misconception, is not just for apps. It's equally relevant for games. A great example comes from Clue, developers of the super popular Subway Surfers app, which was actually the first game to pass the 1 billion install mark on Google Play. When Subway Surfers started using Android Vitals, they discovered a sudden increase in ANR rate, used the reports to identify a cause, and pushed a fix and saw a reduction of their ANR rate from 2% to below 0.1%, a 95% reduction. But I think what's worth calling out here is what we found afterwards. So we did an analysis at Google Play of what was the change of engagement with the app before and after the fix. And we saw really substantive gains in both daily active users and in sessions per users across the board. Now, these are just two examples of developers who have been able to leverage the platform to see really significant gains both at a performance and a business level. Now I'm going to invite up Fergus, product manager for Vitals, who's going to talk about some of the ways that we're enhancing the platform to make it even more powerful for developers.
Great job. Hey everyone, I'm Fergus Hurley, product manager for Android Vitals. It's been incredible to see the improvements that app developers like yourselves have made over the past year as a result of using the tools that we've made available. It's also been incredible to get all the feedback from you as to how we could improve Android Vitals. I'm really excited to show you the new features we have available today as a result of your feedback. So thank you so much. Last year, when we announced Android Vitals, as Joel mentioned, we launched 3 performance areas: battery, stability, and rendering. Today, we're announcing 2 new areas: startup time and permissions. Battery is probably the most important performance area to focus on. This is where you should not unnecessarily use the CPU or the radios on the device, which drains users' batteries, which means they can't use your app as long. Stability is all about building a robust and reliable application so that users are using your application without freezes or crashes. And rendering is all about building a fast and responsive application that's silky smooth and doesn't lag or stall on users. With startup time, we're enabling you to be able to provide a quick launching application to your users, no matter what state your app has been in. There's 3 different metrics we have here, and I'm going to go through each one. So first, we have slow cold start. Slow here is defined as 5 seconds or more. And cold start is when your app has not been launched in a while and is going from activity launched to activity running, and the app is not in memory. Slow warm start is where it takes 2 seconds or more for your app to go from activity launched to activity running, but your app is in memory. Final startup time metric we have is slow hot start. This is where your app goes from on restart to activity running, and it takes longer than 1.5 seconds. This is where your app and your activity is in memory. Another new performance area we have is permissions. This is where we want to help you be able to only request permissions that users think are required for the core value of your application to be provided to them. And if they don't think so, then provide them justification why you think they should actually provide that information. When we ask users, what are the reasons that you deny permissions for applications, what we find is that the vast majority of them just think that the app doesn't need those permissions. So really providing a justification is critical for you to get users to be able to give you the permission that you need to be able to offer the best functionality possible in your application. In the details view for permissions, we provide a breakdown by permission group. So maybe one of your permissions users think your app does need, and you get a high percentage of acceptance for that one. And then another one users don't think you need, and you get a high denial rate for that one. And maybe you don't need that permission in the first place, so maybe you should rethink it, or maybe you just need to explain to users why your app does need that permission. We have many other breakdowns across the Vitals product. For most Vitals, we break it down by app version, by device, and by Android version. For wake locks and wake ups, we provide by tag. For ANRs, we provide by ANR type and ANR name. We also provide the clusters view for grouping your ANRs together so you can be able to see which ones are similar and be able to debug those clusters. For crashes, we also provide clusters. When I've been building apps at Google and prior to Google, one of the things I struggled with the most was being able to understand how do I compare with other apps that offer similar functionality. Who else has struggled with understanding if their app is performing well compared to other apps? OK, lots of people share the same struggle as I've had. We are now going to announce category-level benchmarks in the Play console. This enables you to be able to see, OK, for start time, you can see here that board games are much faster at starting than racing games. And we also provide the 25th, 50th, and 75th percentile breakdown for each of the category-level benchmarks. We'll default to the category that you list yourself in the store, but you can select any other category that you want to be able to compare yourself with in case you don't think that your app is as related to that category. On the details page for every vial, we show you this breakdown for the category benchmark, and then you can be able to also see what exact percentage you are relative to the other apps in that category. On the redesigned Android Vitals overview page, we show you each of the metrics in the performance area. We show you what was your percentage of users impacted in the last 30 days, what was the percentage of users impacted in the previous 30 days, and we show you the benchmark comparison. This enables you to be able to quickly see, OK, which one of these performance areas should I actually look into, and which specific metric might require more attention. And so you can see here the last one on the list, you're in the bottom 12%, so that's probably one you want to investigate. The Weather Channel has been an early access partner for these features that we're showing today for the past couple of weeks. And one of the pieces of feedback that they've had is that it's been really great for them to be able to use category-level benchmarks to make the case within their company as to why they should invest in performance, because they can show how they stack up versus competing apps. I hope you're able to use similar data to be able to make the case within your company. If you want to learn more about benchmarks in the Play console, we have a session on tomorrow at 9:30 a.m. Although all Android Vitals should be viewed as ways to be able to enhance the experience of your application. Some vitals are more important to offering the best user experience possible. And so that's why we're putting this feature at the top of the Android Vitals overview page, which is core vitals. These are the vitals that you should pay most attention to. These are the ones that will impact your promotability and ranking in the store, along with many other signals, but you should really pay attention to these signals. You'll see the list of the vitals. Here we have the initial 4, so stuck partial wake locks, where you hold a wake lock for over an hour in the background. Excessive wake-ups, where you have 10 wake-ups happening per hour. ANR rate, where you have a user experience the app not responding for 5 seconds or more in a day. And a crash rate, where they have 1 crash in a day. If you're in the bottom 25% for any of these these core vitals, then you'll be flagged as having a bad behavior. This is where you'll see a tile at the top of the core vitals section to alert you. And when you click on that tile, you'll be able to go into the details view and see which specific APK is exhibiting that bad behavior. And we provide you the information to help you debug that issue. One other major request that we've had over the past year is to get alerted when there is an issue that's introduced with their vitals. And so we're really happy to announce anomaly detection. So this is where you'll get flagged with an alert at the top of your Android Vitals section, are the ANR and crash clusters, to let you know what is the issue that you have. And you can click on that tile and be able to go in and see details. You can also be able to sign up to get email alerts where when one of these anomalies is detected. And when you get one of those emails, there's a link directly to the issue, so you can be able to investigate, OK, when did this issue occur, and for how long did it happen? The Big Fish Games team that have built many games that have reached over 10 million installs have found great results with using these tools by being an early access partner for these features over the past couple of months. And they've reduced their crash rate by 45% for one of their top games. I'm now going to hand over to Wojtek to talk about how you can debug and improve your specific core vitals issues.
Thank you, Fergus. So hi, everyone. My name is Wojtek. I work on the developer relations team, and I work closely with the Android teams at Google to help you developers build better apps. And today I want to talk about how you can fix some of these core vitals that Fergus mentioned in your apps, in your code. And first, I want to start with the stability. And let's talk a little bit about ANRs. So we keep saying this acronym, right, ANRs, but what are they really? So ANRs, in other words, application not responding events. Now, this happens whenever in your app, some long-running operation blocks your main thread. Now, the main thread is responsible for things like responding to user events, such as taps, or redrawing the UI for every frame. So if we block it, if the main thread cannot do that in a timely manner, the app will just seem frozen. And then after a few seconds, the system will notice that and will pop up this annoying dialog that lets the user actually close the app. And as developers, we really don't want that to happen. So what are some common causes of ANRs? Like, what kind of operations can block our main thread? Well, probably the most common ones are network and disk operations, also called as I/O. Now, networks are congested, remote servers are slow, so can be your flash drives, or the file system can be busy with other operations. And so, as developers, we should never do network or disk operations on the main thread. But you know, I just prepared 2 code examples to show you that it's not always easy to do the right thing. Even though you all probably agree with me, we can still make mistakes. So here, for example, in my activity on create, I decided, well, I'm just going to prepare this shared preferences object to use later. I'm just going to create it and not do anything with it right now. And then somewhere else in my app, probably on a background thread, I will actually get some information like read an integer or a string or whatever. And I thought, OK, that's good. I will not be doing disk operations on the main thread. What I didn't realize, though, is that the implementation of shared preferences on Android actually eagerly reads data from disk the moment you create them. So that's actually the line of code that does disk access. So I was wrong. It's not always obvious. And let me show you another even trickier example. So here, I'm doing some hypothetical network operations in my app. So let's say I want to check if my intent contains some kind of URL. So I'm comparing the two. And then I say, I want to open connection to that URL. I'm going to save the headers to some variable for later use. And then I actually open an input stream. And finally, in the end, I am reading bytes from the network. So this is a pretty complicated API, to be honest. And how am I, as a developer, supposed to know if that first line, open connection, creates the network request and actually blocks my thread? Or is it the last one, where I actually request to read bytes of data to actually read them into my application? Or is it something else? And, well, it's not obvious. Actually, in this example, this line of code will perform a network operation. Like, the first time I'm trying to access headers, only then will the connection be opened and the first bytes will be read. And so as a developer, again, I failed. I didn't know which operation does the network access. But fun fact, on an even older Android version, this line, just checking if two URLs are equal, can perform network operations. OK, so why am I showing you all this? Because I want to convince you that just as developers, we cannot know everything. And you will use libraries that you're not familiar with, or other APIs. And that's why I suggest you use strict mode for your debug builds while you develop your apps. Now, strict mode is an API that existed on Android for a long time. And it's pretty easy to set up. You just set a thread policy in your application on create or in your activity on create. And you tell strict mode, I want you to detect all disk operations in my application on this thread. And I also want you to detect network operations. And then you tell strict mode what you want the result to be. So first of all, of course, we want to see it in logs, so we can debug it later. But logs are easy to miss. Like, logcat can be noisy sometimes. So for my debug builds, I'm also going to go and say penalty death, which will actually crash my app whenever I do the wrong thing and access network or disk on the main thread. Now, like I said, you don't want to do any of that in your production release builds because you don't want your user's app to crash. OK, so now I go back and run my code that I just showed you and look at my logs because my app obviously crashed. And I see the exact cause, and I can go and debug that. So I can see there was a strict mode disk read violation, and I can see in the stack trace the culprit is, it's the get default shared preferences call that I did in my activity on create. So great. This lets me actually go and fix that. OK, so we covered network and disk operations and how to cache them. Sometimes you don't even need to hit remote servers or disk to cause a long-running operation. All it takes is literally just calculating something for a long time, doing a very long loop and something like that. So here in this example, this is a sample Sudoku game. And how it works is when the user opens the app, the Sudoku board is actually generated in memory. It's not read from disk. It's not pulled down from a server somewhere. There's actually a pretty long, complex calculation happening to show that first board to the user so they can play it. So it's this one call, generate board. And as you can see on a slow device, this could cause an ANR because I'm doing that on the main thread. So first of all, how am I supposed to know as a developer that this call, generate board, can be long? Well, I really suggest that you use Android Profiler regularly if you ever suspect there's any performance problem in your app. So here, for example, I took a CPU trace of the method generate board in the Android Profiler, and I can immediately see that it's a complex recursive call that takes a long, long time to finish. And so now I know I should not be running it on the main thread. Oh, and by the way, there's a new thing in the Android Profiler that we just released in the Canary today. Now you can debug and profile your app startup time. So that's pretty handy. OK, so going back to our problem with our generate board call, what can I do with it? So strict mode has this method of telling it that a call can be slow. So here, as a developer, as the person who created this Sudoku algorithm, I will tell strict mode to note the slow call. And now whoever else touches my code and is using it and uses strict mode as well, if they also set the detect custom slow calls thread policy, again, they will get notified. Their app will crash, they will get the log, and they will know to never call that generate board method on the main thread. All right, so what are some other causes of ANRs? Be careful if you're doing any kind of inter-process communication and expect a result. Don't do it synchronously on the main thread. If you're calling some other application, if that call is leaving your process, you basically don't control what happens on the other side. IPC goes through layers of the operating system. The other process can access network and disk to service your request. So just remember to do it on the background thread. The next thing is multi-threaded programming. And that's a really, really difficult topic. Like, we could have a whole other session about this. But if you ever find yourselves touching low-level primitives such as locks and synchronization, eventually there's a high chance you'll create a deadlock in your application or hit some other problem that blocks your main thread. And these are very tricky to debug. However, Android Vitals does give you some information that will help you debug these kinds of problems. So if you open any ANR in the Vitals console, we actually provide you with the trace files pulled from the devices that suffered from these ANRs. So you can look at thread states and see if they were blocked, waiting on any resource to become available. And we even highlight the problems that we think might be happening in this trace. OK, and then the last thing I want to mention is, as a cause of ANRs, is slow broadcast receiver handling. Now, not every developer realizes that if you set a broadcast receiver in your Android manifest, and then it gets called, that the onReceive method actually happens on the main thread. And you're not supposed to perform any long-running operations in it. And there's a timeout, about 10 seconds, that the system will allow this method to run, and then it will kill your process. And so, sometimes, though, whenever you're using a broadcast receiver, maybe to show a notification to the user, maybe you still need a little piece of data, maybe from the disk, like reading some name or profile picture to show in a notification. So you actually need to do that disk access. So what can you do in this case? Now, broadcast receivers have this method called goAsync. It's basically a way to tell the broadcast receiver from the onReceive method that you need to do some longer running operation. And then you spin up a separate thread yourself, you do the operation, and then remember to call finish when you're done. If you don't do that, the system will still realize that you're blocking and might potentially kill your app. And remember, don't treat this as some kind of long-running service. This is not the case for broadcast receivers. And a reasonable time limit still applies. So you should literally just grab the things you need and the separate thread and finish as soon as possible. OK, let's talk a little bit about crashes. And it's really difficult to give general advice on how to avoid crashes in a setting like this, because every app will be different, every crash will be different. However, I can give you some advice that I think might be helpful. So, for years as an Android developer, I've seen my code or code from other people start very simple. And we release something, and then things start crashing on users' devices. And so we add all these safety measures, like checking for nulls everywhere, and checking for activity life cycles. And then if that fails, we just wrap everything in a try-catch and just hope that this problem doesn't hit too many users. But that's not the greatest solution, right? It doesn't actually solve the underlying problem. And that's why my first piece of advice to you is don't try to reinvent the wheel, and use readily available libraries that solve problems that you as developers face. Now, some of the most difficult parts of Android, we heard about it from you, from developers, is handling life cycles. And that's why last year we released the architecture components, such as live data view model, for handling that. And also, we released room and paging components for loading data into your application, into your UI. This year at I/O, we're announcing 2 new components as part of the Android Jetpack initiative. This is navigation for handling all kinds of fragmented activity transitions and navigation problems, and the work manager for scheduling work in the background. But you don't have to use components provided by Google. There are a lot of great third-party libraries out there. And if you think they're useful to you in your application and they will solve your problems, feel free to use them as well. OK, the second thing I want to mention when talking about crashes is Kotlin. Now, also last year at I/O, we announced Kotlin as a first-class supported language for Android developers. And before I say anything more, let me just say that I know it's not a silver bullet. It will not solve all your crashes in your application. However, because of the null safety that's built right into the language, it can save you for some common classes of errors that you might otherwise hit with if you build your apps with just Java. And some of the other nice things about Kotlin are that it's highly interoperable with existing Java code. So you don't have to go all in and transform all your apps into Kotlin. You can start slowly adding it into your applications and see if it helps you. And actually, developers love Kotlin. And we are seeing a steady uptake in Kotlin usage in Android apps. And it's also easy and fun to learn. So I really encourage, if you haven't tried it yet, it's fully supported by us, and you're free to use it in your applications. And the last thing about crashes that I want to talk about is private and hidden APIs. Now, we offer an SDK to developers that's backed by documentation and basically public methods, public interfaces that you can use. But developers are finding ways to access methods in the Android framework that exist on devices that were never intended for you to use. And that's not because we don't like you as developers, we don't want you to give you nice things. It's just because that these APIs are not ready to be used. They're not guaranteed to exist. They might be implementation details on a certain device. We might even remove them on the next Android version, or a device manufacturer can go and customize Android to remove them as well. The thing is, you should never use private or hidden APIs in your apps. But in order to enforce that and to actually help you make your apps crash less in case these APIs change, we're introducing restrictions in Android P Developer Preview that means basically you have to stop using private and hidden APIs in your apps. And we did a similar thing in Android Nougat with the NDK, where we said you can no longer access libraries that exist on the system partition if they're not exposed by public NDK APIs. So please, if you can, migrate from private APIs to public APIs that are documented and guaranteed to work to make your apps safer. And let's talk a little bit about battery and stuck wake locks. So wake locks, it's an API that lets you basically keep the device from entering deep sleep, so from conserving the battery. And a stuck wake lock is when you use the API, and because of a bug or because you forgot, you acquire a wake lock, but you never release it. So it just keeps the CPU running, and it keeps draining the battery on your users' devices. So what's the best way to avoid having a stuck wake lock in your application? Well, you can't have one if you don't use wake locks. That's literally the simplest thing. And actually, in modern Android development, there's rarely a situation when you have to use a wake lock. If we think about activities, so whenever the user is actually using your app, and for some reason you want to keep the screen on, instead of setting a wake lock programmatically, just use a flag on the window that will tell the system to keep screen on. There's no way to leak it. For services, if you schedule them as jobs instead of having your custom free-running services, the job scheduler will hold the wake lock for you. And so again, you don't have to do that yourselves. Similarly, with Alarm Manager, if you use it to schedule an alarm in a broadcast receiver, there will be a wake lock held for you for the duration of on receive. So if you don't use wake locks, you don't even need that permission in your manifest, and you can't leak them. So that's great. But if you must use a wake lock, if you find a situation where you have to use it, remember to always choose a partial wake lock. All the other types of wake locks are deprecated on newer Android versions. And then always set a timeout value in wake lock acquire, so that in case you leak it, the system will clean up the wake lock for you after the timeout expires. Remember to give it a static descriptive tag without any counters or, even worse, like private sensitive information. That way, we can surface the name of the wake lock in the Android vitals for you for easier debugging. And then remember to always code defensively and assume things can go wrong, and use things like try and finally blocks to make sure that you release the wake lock as soon as you're done with it. And the last thing I want to talk about today is excessive wake-ups. And I think the biggest cause for excessive wake-ups is the use of this old API called Alarm Manager, and specifically the wake-up type of alarms. Now, let me give you the 3 R's of Alarm Manager. Remove calls to wake-up alarms if possible. Reduce the frequency if you have to use them for some reason. And if you can, replace your alarms with other APIs, such as Firebase Cloud Messaging, whenever the wake up has to happen for something that changed on your server, and you can send it as a push message. Or use one of the job scheduling APIs, such as the newly announced Work Manager, or even Job Scheduler or Sync Manager. And you know, with intelligent job scheduling, you get a lot of things for free, such as automatic backup and retry if your job fails for any reason. You get criteria-based scheduling, so you can only wake up the device when it has network or is charging, so that you don't actually run your code unnecessarily. You get DOS and standby compliance, and like I mentioned before, even automatic wake lock handling. And there's a whole session about background processing and a Work Manager API specifically, where you can learn more about this today. So I mentioned the Android profiler before, and I'm happy to say that today in Android Studio, we're also announcing the new Energy Profiler, so that you can debug any kinds of problems with wake locks if you use them in your app, and also see detailed information about alarms and jobs scheduled in your application. If you're interested to hear more about the profiler, please go to the session tomorrow. And with that, let me invite Fergus back on stage to talk to you about what more you can do to improve quality of your apps. Thanks.
Great. So we've covered a lot about what's available in Android Vitals in the Play console. I'm just quickly going to go through some of the other tools that you can be able to use to be able to improve the performance of your application. All of Android Vitals is based on data that's collected from users' devices. So these are users that are actually being affected by the issue itself. We would love for users not to actually be impacted by any of these issues at all. And so we'd encourage you to do more pre-launch testing of your application to find these issues before rolling it out to users. There's a session on this on Thursday at 9:30, and I encourage you to attend that one. Over the past couple of years, we've made radical improvements to the Android operating system to help users be able to get more out of their device in terms of performance and for the battery to last longer. There's major improvements with the latest version of Android, and that was covered in the keynote today. You can learn a lot more about that on Thursday at 11:30 in this session here. Wojtek covered a bunch of different tools within Android Studio to help you with improving your core vitals. But there's a bunch of other profilers and tools available to improve all the rest of your vitals. And so I encourage you to use Android Studio, even if you're using another IDE, for example, to build your game. Firebase offers many tools to help you be able to track the performance of your application. Crash Analytics and Firebase Performance Monitoring being the most relevant ones for this talk. We encourage you to use those SDKs if you want to be able to do custom logging of your issues that you might be having with your application. Note there will be a difference in the data that's collected from the Firebase SDK versus what's collected through Android Vitals, which is from users who have opted in to sharing the data with Google and our partners at you. If you want to learn more about Firebase Performance Monitoring and Crash Analytics, you can attend this talk at 11:30 tomorrow. We covered a lot in terms of what's available in Android Vitals in the Play console today, but there's a lot more to learn, and you can hear all about that on developers.android.com/vitals. Just to quickly recap, we started by covering why performance is vital overall, and hopefully you all agree that it is. That's why you're here today, so thank you. Then we covered what's new in Vitals, and I hope you take advantage of these new tools. Then we talked about how you can debug these core Vitals issues. And finally, what's available beyond Play Console Android Vitals. We'd love to hear your feedback on this talk. If you can be able to go to this URL and provide your feedback, we'd love to hear from you. If you have any questions for us, you can meet us from at 4 o'clock to 5 o'clock at this stand. It's on the other side of the lot. And we'll also be available at the Google Play Console Sandbox from 2 p.m. to 5 p.m. tomorrow to answer any of your questions. Thank you all very much for joining us here today. We hope that you'll make radical improvements to your application over the next year and that you'll get covered in our I/O talk next year. So best of luck to you all with improving your application. Thank you.
Hello and welcome back to I/O Live. I'm Timothy Jordan and I'm standing here with Niall and with Shaza, and they built an app using TensorFlow. I'm going to talk about it a little. Niall, could you tell me what the app is and how you came up with the idea?
Sure. So the app is actually a plant classification app. You basically take your camera and hold it over a plant leaf. The app then tells you what type of plant it is. It tells you if it's healthy or if it has a disease and what the disease is. And we actually came up with it one day in lunch. So Shaza had been talking about wanting to create an app, and we were brainstorming some ideas, and I thought about my mom, who has had a huge passion for gardening. About a year ago, we ended up moving, and so she had to transport her garden from a big backyard to a tiny little patio in an apartment. Thus, all of her plants were dying. So we ended up making the app and helping her garden flourish.
Awesome. Now, Shaza, what was it like getting started with machine learning?
Hi, Timothy. I got started with machine learning through a TensorFlow code lab called TensorFlow for Poets, and I learned all about how machine learning works and how to use convolutional neural networks on your own data set using the TensorFlow API.
Did you find that challenging?
It was very challenging. It took me a long time to learn because it was my very first programming experience, but it ended up being a really amazing project.
Awesome. Now, what's next? Do you have any ideas for new apps?
Yeah, so I definitely want to do something that has to do with women in third world countries. I have a really close friend who's actually a national leader in the organization Girl Up, and so their topic is just dealing with women in third world countries. So we're definitely working together right now on something to benefit that.
Awesome. Okay, one last question. Do you have any advice for somebody out there who's looking to get started in machine learning or even just computer science?
To someone who's looking to get started in computer science, I would tell them that it's a lot easier than you think, and there are a ton of resources out there if you want to learn about machine learning or artificial intelligence.
Awesome. Thank you so much. And thank you for joining us. This is I/O Live.
Hi and welcome to I/O Live. I'm Florina Montanescu, your host, and I'm here today with Sasha Preuster, Director of Product of Android TV.
Hi, Florina.
So tell me, Sasha, what's new with Android TV?
Hey, yeah, we have a bunch of stuff that we're excited to talk specifically with developers at Google I/O, because it is a developer conference after all. So we do a lot of talks and sessions here about how TV app developers can actually integrate really well with Android TV. So as you can see on the screen, if I just scroll around a little bit, we want app developers to get their top content and like really beautiful pictures, all the metadata on screen, but we want to make sure it's not only YouTube or HBO that can do that stuff. We want every app developer can do this, right? So we talk a lot about new ways how you can do this integration really nice, what ways we have to help you with this, and basically want to enable developers to have really the best content on the TV and make the content really shine, because we want to help them to make their apps popular, right? And then obviously it's Google I/O, so we're talking about Android P as well. So we have a bunch of new stuff in Android P for users, but also for developers. So some examples for users are we have a very new like fast setup flow that gets you all your favorite apps already when you set up a device. We have features like autofill, where if you have already logged in on some other device, you already get your login credentials on Android TV, so you don't have to clumsily enter passwords with the remote control. No one likes that, right? But also there are cool new platform APIs in Android P, where, for example, with external camera support, so you could start to develop camera apps on TV as well. Yeah, and that's some of the stuff with Android P where you can use the new Android P Preview SDK. It has a TV emulator, and you can get started with that if you want.
So I know last year you launched the Assistant in the US, but I live in London. Can I finally use it in London also?
A very good question. Actually, the international support for the Google Assistant is on Android TV is rolling out as we speak. So specifically the UK and some other European countries rolled out in the next few weeks. But since you mentioned the Assistant, one really cool thing we announced here at Google I/O is our new soundbar project that we did with JBL. It's the JBL link bar that you can see here. And we really like the combination of having a TV device powering your TV screen, but with really awesome sound, and a far-field microphone built in, so you don't really need this remote control anymore. You can basically just sit on the sofa and control your TV device or any device connected to the soundbar. So you can ask things like, "Hey Google, what's my agenda today?"
Today, there's only one thing on your calendar. It's at 6 p.m. and its title is Pick Up the Dog.
Yeah, I really shouldn't forget that. But it's really nice. You don't have to get up from the couch, look for the remote control anymore. You just talk to your TV in a very natural way. "Hey Google, go home."
Okay, great, so I can continue losing my remote control. Thanks. Okay, but still, I'm an Android developer, so what can I do practically? Is there some code that I can already write?
Yeah, I mean, you could download the Android P Preview SDK with your emulator, but we know developers want to work with real hardware. So one really cool thing we're announcing here at Google I/O is the ADT2 developer device. It's for those of you who have been developing for Android TV for a while, might remember we had an ADT1 developer device in 2014, launched at Google I/O, and after 4 years we thought it's time to do that again. So it's a neat little Android TV dongle you can connect to your TV. You can sign up for this. We have a sign-up form live, and we are selecting, it's a limited edition device, but we make sure a lot of developers are getting one of those. It's a real cool, small Android TV dongle, voice-enabled remote control, so all the things we've been talking about, a content integration, assistant integration for your apps, you can try that all out on the device.
Okay, great. Thank you very much, Sasha. So we already have a lot of new things for Android TV, both for developers and for end users. So now all we need to do is check out the developer documentation and also sign up for the dongle. Thank you, Sasha.
Thank you.
This is Florina for I/O Live. To make Android development with Kotlin more clear, pleasant, and idiomatic when working with Android framework classes, we created Android Kotlin extensions, a set of extensions to the framework that cover some of the most commonly used classes like View, Shared Preferences, Canvas, Animator, and others. For now, Android KTX is in preview, and the API is likely to change before reaching the stable version. But here's how to integrate it in your projects to check it out, some examples of usage, and how you can contribute. In the build.gradle file of our app, add the Google repository, if it's not there already, and then add the Android KTX library to your dependencies. Let's start with a simple example. Let's say that we want to create a URI from a string. Normally, you would call URI.parse on the string, but with Android KTX, we can just call toURI on the string. When we want to save a value in Share Preferences, our code will look like this. We edit the preferences, put the value, and then call apply. With the extension, we just need to call edit and pass a lambda block with the action. Under the hood, it actually does the same thing as the previous code. Working with classes from the graphics package, we've added extension functions for some of the most important classes there: Canvas, Bitmap, Path, Color, and others. So let's say that we want to draw the difference between two paths offset downward by 100 pixels. First, we get the difference of the paths. Then we translate the canvas, and afterwards we draw the new path. All of this code can now be simplified like this. Okay, let's take another example, this time with a view, and say that we want to execute an action before the view is drawn. The default implementation requires us to add an onPredraw listener, make sure it's removed before the action is triggered, and then trigger the action. With Android KTX, we can just call doOnPredraw on our view and trigger the action. These are just a few of the extensions available so far. Check out the docs to find out what else we have there. If you want to suggest more ideas for extension functions and you'd like to contribute, check out the Android KTX GitHub project. We're still in preview, the API is not stable yet, so your feedback is valuable and can shape the library. This is just the beginning of Android KTX. We're working on extensions for support library and architecture components. Kotlin on Android is here to stay, and we have big plans for it. Follow us on GitHub, YouTube, and Twitter for more news.
Hello and welcome back to I/O Live. I'm Timothy Jordan and I'm standing here with Niall and with Shaza, and they built an app using TensorFlow. I'm going to talk about it a little. Niall, could you tell me what the app is and how you came up with the idea?
Sure. So the app is actually a plant classification app. You basically take your camera and hold it over a plant leaf. The app then tells you what type of plant it is. It tells you if it's healthy or if it has a disease and what the disease is. And we actually came up with it one day in lunch. So Shaza had been talking about wanting to create an app, and we were brainstorming some ideas, and I thought about my mom, who has had a huge passion for gardening. About a year ago, we ended up moving, and so she had to transport her garden from a big backyard to a tiny little patio in an apartment. Thus, all of her plants were dying. So we ended up making the app and helping her garden flourish.
Awesome. Now, Shaza, what was it like getting started with machine learning?
Hi, Timothy. I got started with machine learning through a TensorFlow code lab called TensorFlow for Poets, and I learned all about how machine learning works and how to use convolutional neural networks on your own data set using the TensorFlow API.
Did you find that challenging?
It was very challenging. It took me a long time to learn because it was my very first programming experience, but it ended up being a really amazing project.
Awesome. Now, what's next? Do you have any ideas for new apps?
Yeah, so I definitely want to do something that has to do with women in third world countries. I have a really close friend who's actually a national leader in the organization Girl Up, and so their topic is just dealing with women in third world countries. So we're definitely working together right now on something to benefit that.
Awesome. Okay, one last question. Do you have any advice for somebody out there who's looking to get started in machine learning or even just computer science?
To someone who's looking to get started in computer science, I would tell them that it's a lot easier than you think, and there are a ton of resources out there if you want to learn about machine learning or artificial intelligence.
Awesome. Thank you so much. And thank you for joining us. This is I/O Live.
Hi and welcome to I/O Live. I'm Florina Montanescu, your host, and I'm here today with Sasha Preuster, Director of Product of Android TV.
Hi, Florina.
So tell me, Sasha, what's new with Android TV?
Hey, yeah, we have a bunch of stuff that we're excited to talk specifically with developers at Google I/O, because it is a developer conference after all. So we do a lot of talks and sessions here about how TV app developers can actually integrate really well with Android TV. So as you can see on the screen, if I just scroll around a little bit, we want app developers to get their top content and like really beautiful pictures, all the metadata on screen, but we want to make sure it's not only YouTube or HBO that can do that stuff. We want every app developer can do this, right? So we talk a lot about new ways how you can do this integration really nice, what ways we have to help you with this, and basically want to enable developers to have really the best content on the TV and make the content really shine, because we want to help them to make the apps popular, right? And then obviously it's Google I/O, so we're talking about Android P as well. So we have a bunch of new stuff in Android P for users, but also for developers. So some examples for users are we have a very new like fast setup flow that gets you all your favorite apps already when you set up a device. We have features like autofill, where if you have already logged in on some other device, you already get your login credentials on Android TV, so you don't have to clumsily enter passwords with the remote control. No one likes that, right? But also there are cool new platform APIs in Android P, where, for example, with external camera support, so you could start to develop camera apps on TV as well. Yeah, and that's some of the stuff with Android P where you can use the new Android P Preview SDK. It has a TV emulator, and you can get started with that if you want.
So I know last year you launched the Assistant in the US, but I live in London. Can I finally use it in London also?
A very good question. Actually, the international support for the Google Assistant is on Android TV is rolling out as we speak. So specifically the UK and some other European countries rolled out in the next few weeks. But since you mentioned the Assistant, one really cool thing we announced here at Google I/O is our new soundbar project that we did with JBL. It's the JBL link bar that you can see here. And we really like the combination of having a TV device powering your TV screen, but with really awesome sound, and a far-field microphone built in, so you don't really need this remote control anymore. You can basically just sit on the sofa and control your TV device or any device connected to the soundbar. So you can ask things like, "Hey Google, what's my agenda today?"
Today, there's only one thing on your calendar. It's at 6 p.m. and its title is Pick Up the Dog.
Yeah, I really shouldn't forget that. But it's really nice. You don't have to get up from the couch, look for the remote control anymore. You just talk to your TV in a very natural way. "Hey Google, go home."
Okay, great. So I can continue losing my remote control. Thanks. Okay, but still, I'm an Android developer. So what can I do practically? Is there some code that I can already write?
Yeah, I mean, you could download the Android P Preview SDK with your emulator, but we know developers want to work with real hardware. So one really cool thing we are announcing here at Google I/O is the ADT2 developer device. It's for those of you who have been developing for Android TV for a while, might remember we had an ADT1 developer device in 2014, launched at Google I/O, and after 4 years we thought it's time to do that again. So it's a neat little Android TV dongle you can connect to your TV. You can sign up for this. We have a sign-up form live, and we are selecting, it's a limited edition device, but we make sure a lot of developers are getting one of those. It's a real cool, small Android TV dongle, voice-enabled remote control, so all the things we've been talking about, content integration, assistant integration for your apps, you can try that all out on the device.
Okay, great. Thank you very much, Sasha. So we already have a lot of new things for Android TV, both for developers and for end users. So now all we need to do is check out the developer documentation and also sign up for the dongle. Thank you, Sasha.
Thank you.
This is Florina for I/O Live.